Hello! In this video we will look at examples with angles and triangles. In this example, we want to find the angles BAC and angle BCA. We start with the fact that angle BCA and angle BCD are supplementary. Substituting angle BCD isolating angle BCA, we get it is equal to 62 degrees. Then to find angle BAC, we use the fact that the angles add up to 180 degrees. Now plug in the values for angle ABC and angle BCA. Simplify and subtract to angle BAC. And we get angle BAC is 52 degrees. Next example. First, we use the fact that angle BCA is equal to 180 minus angle BCD because of supplementary angles. Also, angle BCA plus the other two angles in the triangle add up to 180 degrees. Now we can substitute angle BCA into the second equation to get an equation with just x. Now we can simplify. Isolate the x term. And we get x equals 14. Now we can find angle CAB by plugging in 14 for x. Simplifying, we get angle CAB is 55 degrees. Now let's find angle ABC. Plug in 14 for x and evaluate. So angle ABC is 89 degrees. Then let's find angle BCD. So angle BCD is 34 degrees. Angle ACB is equal to angle BCA. We get 46 degrees for angle ACB. Next example. First, we can write an equation for angle ACB using the supplementary angles postulate. We can also use the supplementary angles to write an equation for angle CAB. We do the same for angle ABC. Now we can write the sum of those angles add up to 180 degrees, and we will have an equation with just x. Combining some like terms. Isolating x term. Dividing both sides to get x by itself. Now we can find the measure of angle ACB by plugging in 15 for x. Evaluating, we get 110 degrees. Angle ABC is congruent to angle CBA. So plug in x and evaluate. So angle CBA is 48 degrees. Angle BAC is congruent to angle CAB. Evaluating, we get angle BAC is 22 degrees. And we have done it. Let's look at some examples with polygons. Here, polygon ABCD is congruent to polygon WXYZ. So we know AB is congruent to segment WX. So substituting their corresponding expressions, and we then solve for x. So solving for x, we get x equals -1. Finding the length of segment AB, we plug in -1 for x. And the length of segment AB is 2. Since AB is congruent to segment XY, it is also equal to 2. We can verify this by plugging in 2 for x. To find angle BCD, we note that it is congruent to angle XYZ. Then we can set their expressions equal to each other and solve for x. Solving for x, we get 11. Note, this is a different x than the previous example. Sorry, I should have used another variable, like y. To find angle BCD, we plug in 11 for x and evaluate. Evaluating, we get 133 degrees. And angle XYZ is congruent to angle BCD, but we can also verify it by plugging in x. Next example. Given the two triangles are congruent, we can see that segment AB is congruent to segment DE. Setting the two expressions equal to each other, we can then solve for x. Getting the quadratic equation in standard form so we can solve by factoring or the quadratic formula. Looks like we can factor factors of -10 that add up to 3, 5, and -2. Solving, we get x equals -5 or x equals 2. But x equals 2 is the only one that will work. To find the length of segment AB, we just plug in 2 for x. Evaluating, we get segment AB is 22. We can plug in 2 for x to find the length of DE, or realize that it is congruent to segment AB. Now let's find the measure of angle DEF. Looking at the triangles, we can see that angle ABC is congruent to angle DEF. Also, angle EDF is congruent to angle BAC. So using the triangle sum postulate, we can write an equation to find angle DEF. Writing that the sum of the three angles is 180 degrees. Then substituting the values for the known angle values. Simplify a bit. Subtract 147 from both sides to isolate angle DEF. We get angle DEF is 33 degrees. Note, angle DEF is also congruent to angle ABC.